Welcome to multi-attribute decision-making, preemptive goal programming. So the book defines preemptive goal planning as a method utilized to address multiple objectives that need to be satisfied in order to get an optimal solution. This method involves incorporating deviational variables on the objective goals that become constraint when creating the simplex form of an LP. These deviational variables are defined by SI plus, which is the amount that we exceed the ith goal, and SI negative, which is the amount we are numerically under the ith goal. For goal programming, the goals must be ranked in order of most important to least important, and the coefficient Pi will represent this ranking when solving the problem. However, this ranking is arbitrary and can change depending on what it is defined as at the beginning. If a problem doesn't indicate how to weigh the goals, then the LP objective function will be replaced by the following formula of min or max z equals P1 S1 negative plus P2 S2 negative plus P3 S3 negative. Adding Sn negative minus Sn plus to each of the original constraints created by the goals. The basic steps of goal programming with the simplex method is that row zeros will be based on the number of goals needed to be satisfied, and then you would use the highest priority goal and find the highest positive coefficient in that row to make that variable a basic variable. But there's the exception that if that variable with the highest positive coefficient has a negative coefficient in row 0, then it cannot be used and you'd have to move on to the next goal. And then for every pivot performed, row 0 for each goal is updated, and the optimal solution is found when row 2 cannot be performed anymore.
For this, we will be using an example from the book, and it wants us to use this problem as a TV advertising schedule, and it has 3 major goals. The first one would be to reach at least 40 million for high-income men. We'll be calling that HIM. And then for goal 2, we'll reach at least 60 million income for low-income people. We'll call that LIP, LIP. And then for goal 3, we'll reach 35 million for high-income women. Call that HIW. And then what the problem state question is how many football ads and soap opera ads should be purchased to come as close as possible to satisfying all 3 goals without exceeding 60 million in the budget. And then if you see in the next slide, there will be a linear program that the book gives us where it's going to be the minimum as z equals P1 S1 plus P2 S2 plus P3 S3. And then we can break these 3 variables into 3 separate equations for row 0, and we put this as goal 1, and we set it up as z1 plus 7 P1 x1 plus 3P1 x2 minus P1 S1 plus equals 40P1, and that would be the HIM goal for the high income men. And then we split up the other one for goal 2, and that would be Z2 plus 10P2 x times x1 plus 5P2 times x2 minus P2 S2 plus, and that would be equaling to 60P2. That would be for the second goal for low income population. And then for goal 3, you would have Z3 plus 5P3x1 plus 4P3x2 minus P3S3 plus equals 35P3, and that would be for the high income women. And then we would use that for our table or tableau, and we would get a optimal tableau for our goal programming for this problem.
Furthermore, for the simplex table, we will also be utilizing the original constraints as well, without using the p coefficients. We'll be using the normal coefficients found in the constraints. So that leads us to, like Steve mentioned, the initial tableau. Let's just finish up writing these original constraints real quick, where we would like to note that we are grabbing the three goals that we have are broken up into row 0, but the only constraint, the budget constraint, since it's not a goal, is not going to be written as a row 0 goal, which we have as 100x1 plus 60x2 is less than or equal to 600. And of course, we also want to make sure all these variables are greater than 0, or at least all variables are non-negative. So with all the constraints identified and all the goal functions identified, we can go ahead to the initial tableau. So for the initial tableau, we are taking the objections and the constraints. We get the following simplex tableau, with row 0 being the 3 goals that were identified as a need that include the p coefficients, and the following rows are the same constraints with just the coefficients assigned. After setting up the simplex tableau using the preemptive goal program model, solving it is similar to the simplex method, in which we look at the first constraint / goal with the highest coefficient and turning it into a basic variable. Of course, this time ensuring that there isn't any variables in that row that is negative. If there is, then we can escape that constraint and go on to the next constraint. So with this problem, we find that from constraint 1, the highest variable is x1, in which after applying the ratio method, we find that we could apply it as a base in the HIM constraint. After summarizing the tableau again, we look to constraint 2 and find that S1 plus is the next variable that is the highest to turn into a basis. Again, using the ratio method, we can insert it into the budget row or lip, and we'll decide to put that into the budget constraint. After performing all the basic row operations, we get the following optimal tableau. So from this tableau, the optimized tableau tells us the following. Goal 1 and goal 2 are met because z is equal to 0. Second thing is we can't achieve goal 3 without violating the higher goals, which goes back to what we defined in preemptive goal programming, that we want to ensure that we have higher importance goals. And then lastly, the preemptive goal programming solution is to purchase 6 minutes of football ads and no soap opera ads, but Chrysler will fall 5 million exposure short. Let me scroll down here a little bit. Short of meeting goal 3. And this can be seen from having Z3 of the goal of row 03, Z3 equals 5P3. We would want that if the goal was met, that would be 0, but since there is a 5 left over, we'll be falling 5 million short. With that, that is our lecture on preemptive goal programming. Thank you for joining us. This was Group 9. Thank you.